Hello students. In the last session we discussed related to the freely falling body. Now we are going to discuss about vertically projected body. Vertically projected body. So if any one body is projected vertically upwards, so what happened? So of course we know that due to the gravitational force of attraction the body will come down. If any body, if you want to project permanently, means it's never come back. So means with what speed we have to project? Yes, of course, with escape velocity we have to project. So now here we are going to discuss about the vertically projected body and how the factors are affecting the vertically projected body. So let's see here, vertically projected body. And here mass is independent. Now here we are considering a body is projecting vertically upwards with u velocity. So initial velocity u. So when the body is going upwards, so what will happen? Due to the effect of the gravity, means the acceleration due to gravity is acting downward direction. Due to the effect of the gravity, the velocity of the body is gradually decreases. At a particular point, the velocity, the final velocity of the body is 0. At a point, the final velocity of the body is 0. See here, initial velocity u and final velocity v, which is equal to 0. And afterwards, the body is actually like a freely falling body. Afterwards, the body acting like a freely falling body. So for example, here the body covers a displacement of h meters and acceleration due to gravity what we can able to take, so which is going retardating condition. So let me try to apply the equations of motion. So let's see, we'll take the first equation of motion. So generally what is the first equation of motion? V is equal to u plus at. So final velocity 0, initial velocity u minus gt. Then we can take here gt is equal to u, then t is equal to u by g. T is equal to u by g. So actually this time is nothing but the time taken by the body to reach the highest position. So this is called actually time of ascent. What we can call as it is as time of ascent. Time of ascent. So the time taken by the body to reach the highest point. Where which reach the highest point? At that point final velocity 0. Final velocity 0. This is the first equation of motion. Let's move to the second equation of motion. What we are taking, s is equal to ut minus half gt square only. S is equal to ut minus half gt square only. Means actually by this expression what we can able to find at any instant of time what about the position of the particle. At any instant of time what about the position of the particle. To get the h value you have to substitute t, but that is going very lengthy expression. Very lengthy expression. Then what is the use of this expression? So if you are seeing that this we can take s is nothing but displacement ut minus half gt square. Means the displacement of the body at any instant of time. Displacement at any instant. At any instant. Let's see the third expression. Again we will see that. Let's see the third expression. What is the third expression? So we know that v square minus u square is equal to 2s. V value 0 minus u square is equal to 2 into minus g into displacement which is going to cover h. So then we can able to write minus minus gets cancelled, then u square is equal to 2gh. We can able to write u square is equal to 2gh. Then h is equal to, we can take u square upon 2g. So this h is named as maximum height. What we are named as maximum height. So what is the meaning of the maximum height? So if you are giving the definition for this, the definition of the maximum height. For a vertically projected body, the point at which the final velocity is 0. For a vertically projected body, the point at which the final velocity is 0, and that displacement or that height we are named as maximum height. So here we got two major definitions or two major equations. One is a time of ascent, how much? U by G. And the other one is a maximum height. What is that? Maximum height. How much? U square by 2g. U square by 2g. Time of ascent. The time taken by the body to reach the maximum height is called time of ascent. And H max, maximum height. Maximum height is nothing but simply for a vertically projected body, the point at which the final velocity is 0. For a vertically projected body, the point at which the final velocity is 0, and that we are named as simply H max. H max. And so we are getting these expressions from this. And in case if you are applying these equations of motion for vertically projected body at any instant of time, that is most important, at any instant of time, not up to the mark, not up to the maximum height, at any instant of time. At any instant of time means in the middle journey. At any instant of time, what about the values of that at any instant of time? So let's see here. So I am considering initial velocity u and final velocity not 0, because at any instant of time means here we are projecting the body from the ground with initial velocity u. At some time after t time, its velocity is v. After t time, its velocity is v. So, and by the time it may covers a displacement h. By the time it may covers a displacement h. And body is going upward, so that's why z is we can take it as minus. Why it is minus? The body is retardating. Retardating means its velocity gradually decreases. When which is going upwards now, its velocity gradually decreases. That's we are named as retardation. Retardation. Now try to apply the equations. First expression, v is equal to u plus at. If you take this, v is equal to velocity, initial velocity u, acceleration g t. So this is the velocity at any instant of time after t seconds. For example, when we can use this expression, a body is projected with a velocity of 5 meter per second. After 1 second, what about the velocity? A body is projected with 10 meter per second. After 1 second, what about its velocity? If you are getting these questions, this kind of questions, so then you have to solve. So next, take second expression. Second expression, already I am giving this displacement at any instant of time. S is equal to ut plus half at square. Here we can able to write h is equal to ut minus half gt square. H is equal to ut minus half gt square. So like that we can able to take. And the third expression, v square minus u square is equal to 2as at any instant of time here. So actually what happened there, the value is goes to minus here. So then that final velocity is going to u square minus 2gh, u square minus 2gh. And one more last and as well as important expression, that is the fourth equation of motion. The fourth equation of motion we are taking Sn is equal to u plus a by 2 into 2n minus 1. In this expression, Sn at any instant of time, u minus g by 2 into 2n minus 1. So like that we can able to take that, like we can able to take Sn is equal to u minus g by 2 into 2n minus half. So like that we can able to find or solve the vertically projected body equations. So just we saw that the time of the ascent, how much time is taken to reach the maximum height. And again the body is going upwards na compulsory, which is coming downwards. So how much time is taken to reach the ground? That's also we have to take. How much time taken to reach the ground? That is called time of descent. To further time of descent, so after reaching of maximum height, again the body starts to fall with zero velocity, right? And how much displacement that has to be covered? Yes, of course, H max. So then you can take simply S is equal to ut plus half gt square formula. So now the motion, the particle reaches the highest point. Now we are taking from highest point to down, highest point to down. So here initial velocity is 0 and it has to be going to cover the displacement as h max. And what about the acceleration? In downward conditions we have to take plus g. So then we can take h max is equal to 0 plus half gt square. So this t is nothing but time of descent. How much time taken to reach the ground from maximum height? That's we are named as time of descent. So then h max in the previous expression, if we are projecting the body with u velocity, then yes, h max is u square by 2g is equal to half g td square. So 2 cancel, you can send here. So then td square is equal to u square upon g square. Then time of descent td is equal to u by g. So time of descent is equal to u by g, the time taken by the body to reach the ground from maximum height. Time of ascent u by g, time of descent u by g. So actually this is both are same only, that I can able to say that, but you may have some doubt how it is like this. So under the absence of air resistance, if there is no air resistance, then time taken by the body to reach the maximum height is equal to time taken by the body to reach the ground. Next we'll see time of flight. Time of flight. Time of flight is nothing but total time. Yeah, time of flight is nothing but total time. So here time of flight we are taking. Time of flight is equal to time of ascent plus time of descent. Time of flight is equal to time of ascent plus time of descent. So the time of ascent u by g plus time of descent also u by g. Then total time is goes to 2u by g. So the total time of flight is 2u by g. Time of flight, the time taken by the body, vertically projected body to reach the ground. To reach the ground, total time. Time of ascent, time of descent, that is equal to time of flight. Okay, this vertically projected body with what velocity that strikes the ground? That's also very important. Yes, yes. Under the absence of gravity. Under the absence of gravity. So the vertically projected body, so the body with what velocity we are striking, again the body reaches with the same velocity. So see here, we are projecting the body with u velocity, which reaches the maximum, and again which is coming down, and with v velocity I am considering v velocity, and I know the total time. How much the total time? Yes, of course, the total time of travel is equal to 2u by g. Total time of travel is equal to 2u by g. And initially we are projecting, means I am considering this is as a totally as one case, not like this. This we are considering like up to the maximum height and maximum height to ground. But here I am considering only one case from ground to and again to the ground. Maximum height not like that. So now acceleration due to gravity value is minus g initially. So now if you are taking v is equal to u plus at value, then v is equal to u minus gt. Actually what is the t value? How much time taken? 2u by g. So then v is equal to u minus g into 2u by g. G gets cancelled, then v is equal to u minus 2u then v is equal to minus u. What is the meaning of minus u? Yes, v is equal to u magnitudely, but directionally opposite. The velocity of projection is equal to velocity of striking in opposite side. Velocity of striking in opposite direction. Velocity of striking in opposite direction. That's the meaning of that. So the v striking with what velocity the body strikes, which is equal to minus u projection. U is nothing but projection velocity. Very important and as well as easy expression. Let's see now, just we discuss related to with what velocity the body strikes the ground. Now we will see one application here. A body is projected vertically upwards. Body is projected vertically upwards with u velocity. So what is the velocity at half of the maximum height? What is the velocity at half of the maximum height? Velocity of vertically projected body at h max by 2. That is the question. H max by 2. That is the question. See here, we are considering the body. I am projecting the body vertically upwards with some u velocity. After traveling of half maximum height, what about the velocity? What about the velocity? H max by 2 here. What about the velocity? There are two conditions, two easy methods to solve this question. First method. So a final velocity is 0. And here how much displacement? Half displacement. Here how much displacement? Half displacement. Right now? In kinematics only we solved one problem here. A body is travels A point and B point, which crosses A point with u velocity, B point with v velocity, and midpoint with what is the velocity at the midpoint? What is the velocity at the midpoint? That question, if you remember that, the velocity at the midpoint is equal to under root u square plus v square by 2. The velocity at the midpoint is equal to under root u square plus u square by 2. So now here the velocity at the midpoint only it is. Midpoint is u square v square 0 by 2, nothing but simply u by root 2. And you may ask that, sir, we are not, we don't know this method. No problem. We'll go to the normal method. The normal method is nothing but simple. What we have to consider here, the motion initial velocity u and the velocity we need to get after a displacement of s is equal to h max by 2, and vertically projected body A is equal to minus g. Vertically projected body A is equal to minus g. So at this point, what is the velocity? That's we have. That's we need. So now see here what we can able to take. V dash square minus u square is equal to 2as. So just put the value. V dash square minus u square is equal to minus 2g into h max upon 2. Minus 2g into h max upon 2. Keep like that only. Now this v dash square is equal to u square minus 2g into h max value. You can substitute h max value how much? U square by 2g. H max value how much? U square by 2g. 2g gets cancelled. Then the v dash square is equal to u square minus u square by 2. Then v dash square is equal to u square by 2. Then v dash is equal to u by root 2. Say u by root 2, u by root 2. This is simple method. If you know this method, then you can able to apply, or otherwise this you have to apply. Next, how much time taken to reach half of the maximum height? Same question. How much time taken? Time taken to reach h max by 2 for vertically projected body. Time taken to reach half of the maximum height. Half of the maximum height. To cover half of the maximum height by vertically projected body. So see here, we consider final velocity. We know the velocity, how much? U by root 2. Initial velocity U, and A is equal to minus G. You require the time. Here, time you require. Let's see here what we can able to take. V is equal to U plus AT. V is nothing but U by root 2 is equal to U minus GT. U minus GT. Then GT is equal to U minus U by root 2. Then T is equal to U. You can take common. Then 1 minus 1 by root 2. How much? 1 minus 1 by root 2. U by G is nothing but time of ascent R. So then T is equal to time of ascent of 1 minus 1 by root 2. So that is simply the time taken by the vertically projected body to reach half of the maximum height. You can try to solve for 3/4 of maximum height. What is that? 3/4 of maximum height. What you have to take for 3/4 of maximum height? Very simple here. You are not able to apply this. So you are not able to apply this. So then you can go this method only. So what displacement as 3/4 of maximum height. 3/4 of h max. And remaining, what is the velocity at this point? What is the velocity at this point means you can apply the same formula. V square minus U square is equal to 2as. Here V square is equal to U square minus 2g into 3/4 of h max. U square by 2g. 2g cancel. So then V square is equal to how much you can get? U square by U square minus U square by 4. That means, sorry, 3U square by 4. Then you can get U square by 4. Then V square, V is equal to U by 2. Where? At 3/4 of maximum height. At a 3/4 of maximum height, what is the velocity? U by 2. Half. Generally, in previous I am asked that half of the maximum height means we thought the velocity also half. No, the velocity is not half. Okay. And one body is projecting from the means a top of tower. We have here a tower. Tower of height. Yes, h meters. From the top of the tower, a body is released, means dropped freely. At the same time, at the same instant, another body is projected vertically upwards with u velocity. Another body means one body is dropped from here and another body is projected vertically upwards. So when they will meet, when means what we have to, when and where actually. So when and where they will meet, they are going to meet. So actually here one is freely falling body and the other one is vertically projected body. One is freely falling body and the other one is vertically projected body. So where they are meet. So the meeting point, if you are taking, the total displacement is equal to h. How much? Total displacement means that plus this. So that means h is equal to the displacement travelled by the freely falling body plus the displacement travelled by the vertically projected body before meeting. Before meeting means when those are going to meet now. What about the displacement travelled by the freely falling body and what about the displacement travelled by the vertically projected body? Then h is equal to the displacement travelled by the freely falling body means it is a velocity 0 na. So that's why what we are taking simply half g t square, half g t square. And displacement travelled by the vertically projected body ut minus half gt square, ut minus half gt square. You can cancel gt square, then h is equal to ut then T is equal to what you can able to take? H by U. T is equal to H by U. Means after H by U seconds, the body is going to both bodies are going to meet. By the time, how much displacement traveled by the freely falling body? How much displacement traveled by the freely falling body means we may get the answer in terms of which means nothing but simply half G T square. So then H dash is equal to half G into H square upon U square. Half G into H square upon U square means we are getting the answer in terms of H and U only, because you know only H and as well as U. So after this displacement means before meeting, the freely falling body covers this much displacement. What about vertically projected body? H minus H dash. So then that covers that much displacement. When those are going to meet, means when those velocities becomes equal, means both bodies, one body gains the velocity, another body loses the velocity. One body gains the velocity, another body loses the velocity. So when those velocities are become equal, means after what time those velocities are become equal. So the velocity of the freely falling body which is equal to velocity of vertically projected body. Freely falling body means it is dropped freely, so that's why U minus G, U value 0, so that's why simply ZT, and this is U minus GT. This is a vertically projected body, initial velocity. Freely falling body, initial velocity 0. So then you can take U is equal to 2GT, then T is equal to U by 2G. Means after this time both will meet. After this time both velocities are equal. In here after this time both will meet. And what about this? Where they'll meet? They'll meet at this distance from top, from bottom, H minus H dash.